Okay, so whenever we graph an inverse in parametric mode, since we don't have graphing calculators at home, it makes this a little more difficult. So we're going to have to learn to graph in Desmos using parametric functions. Desmos does not have a parametric mode like your graphing calculators would if you were in school. So it just makes it a little different. In order to do this, our original function in parametric mode would be first is our x. This is our original function, right? And so our x is just x1, which would be our original. I'm not going to do that part yet. Our original equation would be x1 equals t. In other words, we're going to set this equal to t, and then our y, remember f of x stands for y equals all of this. So y1 would equal this entire function. So it'd be 0.7x to the fifth plus 0.3x to the fourth minus 0.2x to the third plus 2x plus 0.5. Now, if you had your graphing calculator, it would make graphing this easy. But you don't. I'm going to show you how to do it on the graphing calculator anyways, just because, to show you how much easier it is. And it doesn't actually become all that difficult. Oh. Stop. I don't care. All right, so let's turn the calculator on. To graph it, we go to Mode. And then you see where it says Func? Go down to Func and over to Parametric. Push Enter. Then if you go to your y equals, you'll notice that it's x1 of t. So that would just be our x. You push xt theta n. So that would just be t. Push Enter. And then you enter your equation in 0.7x, which is now a t to the fifth plus 0.3 t to the fourth minus 0.2 t to the third plus 2x, which is now 2t, plus 0.5. And now whenever I graph that, it gives me this parabola. Not actually a parabola, but just a line going upwards, right? Then you messed up. Go back into your y equals, make sure that it's t and that you have everything entered in correctly. Not square root of 5 to the fifth. Now I'm going to show you how to graph that on Desmos. So if we just go into Desmos now, and now you're going to treat it like you already know what the parametric version is. You're going to do a parenthesis and t, comma, this looks like it's not going to work, 0.7 t to the fifth plus 0.3 t to the fourth minus 0.2 t to the third. It's supposed to be a 2. Plus 2t, and then plus 0.5. Okay, well that actually worked out pretty well. So you just enter what your x equation is into the first one, and then what your y is into the second one. So now going back to yesterday, when we did our notes, that's our original function. How do you think we would graph our parametric function? Or our inverse function, not our parametric. When we're graphing the inverse function, we just flip it. Like yesterday, we just flipped our x and y coordinates. It's the same thing here. I'm going to take this. This is now my x2. And this is y2. If I'm putting it in the graphing calculator. Otherwise, if I'm doing it in Desmos, you don't have to worry about x2 and y2. I just need to put it into my function. And that's where Desmos will actually come into advantage here, because I can copy and paste. Maybe. Oh. Oh. That doesn't work. There is a way to do this. Watch how I do it. You click the little settings button, and that's not it. You click duplicate, not delete all. Now I can just switch my order, put this one first, comma, and then T. And now that's my parametric function. I can change the color of this too somehow. Click in settings maybe. Yeah, click that. There we go. Done. And then if I put my line y equals x in there, you're going to see that this reflects perfectly over y equals x. Like if I click on rando points or not. Yeah. All right, well, you know, I'm just trying to come up with solutions to a problem that we previously didn't have an answer for. So that's how I would graph it, though. The whole point is you just flip your x and y whenever you're doing it in parametric mode as well. Especially on Desmos, you just put it in the parentheses, like it's an ordered pair, and just graph it that way. That creates a parametric function. Like and subscribe if you like that solution to a problem that we had. And we're going to move on to the next. Algebraic representations of inverses. So suppose a function is represented by an equation in x and y. And the inverse of the function is found by exchanging the input and output values. That means by exchanging x and y. That's what we did in our tables, right? We just switched where the x was and where the y was. Now we're going to learn how to do it with an equation. And all in all, this section is actually easy because we just keep following the same principle. We're going to switch the x and y, and we're going to remember to like and subscribe. So first, I write the function in terms of x and y. So I'm going to replace the g of x or the f of x with a y. So it's y equals 3x minus 2. Then I exchange the x and y, meaning I make this now x equals 3y minus 2. Now I just solve for y like we've been doing since Algebra 1. Add the 2 over. It gives me x plus 2 equals 3y. Divide by 3. And I get y equals x plus 2 over 3. Change that y back into g of x because it says we had to make it g of x. And our inverse to 3x minus 2 is x plus 2 over 3. All right, that's it for today. We're going to practice more tomorrow, as well as learn more about inverse functions, and we'll go from there. All right, guys, have a great day. Like and subscribe, finish your homework.